Hello, my name is Kwakaitin TG22020, and this video presentation is prepared for the course BTE4733 Sensor Technology. The title of my presentation is Air Pollution Monitoring, Comparison between NDIR and Metal Oxide Gas Sensor. In this video, I will explain air pollution, its impacts on the environment and human health, the sensor used to detect air pollutants, the working principle of MDIR and metal oxide gas sensors, and the possible solutions to reduce the air pollution. Air pollution occurs when harmful gases and particles are released into the atmosphere. Common air pollutants include carbon dioxide, carbon monoxide, methane, nitrogen dioxide, and volatile organic compounds. These pollutants mainly come from vehicle exhaust, industrial activities, power plants, and fuel combustion. Most air pollutants are invisible and cannot be detected by human sense. Therefore, sensors are required to monitor and measure the air quality accurately. Air pollution has serious effects on both the environment and human health. From an environmental perspective, gases such as carbon dioxide and methane contribute to global warming and climate change. Air pollution can damage crops, forests, and ecosystems, leading to long-term environmental degradations. From a human health perspective, prolonged exposure to the polluted air can cause the breathing problems, asthma, headache, dizziness, and cardiovascular diseases. In several cases, air pollution can lead to premature death because of these impacts. Effective air pollution monitoring is essential. Air pollution sen- Air pollution sensors play an important role in detecting and monitoring harmful gases in the air. Why are gas sensors needed? Because pollutant gases are invisible, the presence of sensors can detect and measure the gas concentration, thus can enable the air quality monitoring. These sensors provide real-time data that can be used by governments, industries, and environmental agencies to control emissions and ensure the public safety. In this presentation, two types of gas sensors will be discussed, which are the NDIR gas sensors, metal oxide gas sensors. Both sensors are widely used in air quality monitoring applications. In this slide, you can see this is the NDIR gas sensors, and the other side one is the metal oxide gas sensors. NDIR gas sensors. NDIR stands for non-dispersive infrared. NDIR gas sensors are mainly used to detect the gases such as carbon dioxide. They operate based on the principle of infrared light absorptions. NDIR sensors are known for their high accuracy, stability, and long operational lifespan. The working principle of an NDIR gas sensor is based on the absorption of infrared radiation or by the gas molecules. Certain gases, such as carbon dioxide, can absorb infrared light at specific wavelengths due to the molecular vibrations. And NDIR sensors consist of an infrared source, a gas chamber, an optical filter, and an infrared detector. First, the infrared source emits the infrared radiation into the gas chamber. The emitted radiation contains a range of the infrared wavelengths. Next, an air sample enters the gas chambers. When the carbon dioxide is present, it absorbs the infrared light at its characteristic wavelength, which is approximately 4.26 micrometers. An optical filter is used to ensure that only the infrared wavelength absorbed by the carbon dioxide reaches the detector. This makes the sensor highly selective for specific gases. The infrared detector measures the amount of light that reaches it after passing through the gas chamber. If a higher concentration of the carbon dioxide is present, more infrared light is absorbed and less light will reach the detector. The detector converts the reduced light intensity into an electrical signal. This signal is processed by the sensor circuitry and calculate the gas concentrations, usually expressed in parts per million. In summary, the NDRL sensor determines the gas concentration by measuring the amount of infrared light absorbed by gas molecule. Metal oxide gas sensors, also known as MOS sensors, are commonly used to detect gases such as carbon monoxide, methane, and volatile organic compounds. These sensors are popular due to their low cost, high sensitivity, and compact size. However, metal oxide sensors generally have lower selectivity compared to the NDIR sensor. The working principle of a metal oxide gas sensor is based on changes in electrical resistance caused by the surface chemical reactions. The sensing element of a metal oxide sensor is typically made of tin dioxide, which is an N-type semiconductor material. A key component of the metal oxide sensor is the built-in heater. The heater increases the temperature of the sensing layer to approximately 200 to 400 degrees Celsius. When in the clean air, the oxygen molecules are absorbed onto the surface of the metal oxide layer. These oxygen molecules capture free electrons from the sensing materials, forming an electron depletion layer and increasing the electrical resistance of the sensor. When a target gas, such as carbon monoxide or methane, is present, the gas molecules react with the absorbed oxygen on the sensor surface. This reaction releases the trapped electrons back into the metal oxide layer. As a result, the electrical resistance of the sensor increases. The magnitude of the resistance change is proportional to the gas concentration. Electrode connected to the sensing layer measure this resistance change and convert it into the electrical signal. The signal is then processed to provide the gas concentration output. In summary, metal oxide sensors detect gas by measuring the resistance changes caused by the surface chemical reactions. The comparison between NDIR and metal oxide sensors. NDIR and metal oxide sensors use different detection principles. NDIR sensors operate based on infrared absorption and do not involve chemical reactions. They provide high accuracy, high selectivity, and long-term stability but are relatively expensive. Metal oxide sensors operate based on resistance change caused by the chemical reactions on the sensor surface. They are low cost and highly sensitive but are affected by the temperature, humidity, and long-term drift. The choice of sensor depends on the application requirements. Solutions to reduce the air pollution. NDRR sensors are commonly used in indoor air quality monitoring, HVAC systems, and environmental monitoring stations. Metal oxide sensors are widely used in gas leak detection, industrial safety system, and low-cost air quality monitoring devices. To reduce air pollution, possible solutions include continuous air quality monitoring, emission control in industries, the use of renewable energy, enforcing emission regulations, and improvements in the public transportation system. Sensors play a critical role in supporting these solutions by providing accurate and real-time data. In conclusion, air pollution poses serious risks to both the environment and human health. NDIR gas sensors and metal oxide gas sensors are widely used technologies for detecting air pollutants. NDIR sensors offer high accuracy and stability, while metal oxide sensors provide low cost and sensitive detections. By selecting the appropriate sensor technology, effective air pollution monitoring and control can be achieved. The reference used in this presentation include textbook, journal article, and technical report related to gas sensing technology.